Hey YouTube, what's going on? Today I'm going to create a simple API using Python and FastAPI. This is probably going to be a series of 2 or 3 videos. So the first video, this one, will be on creating a simple API. In the next video, I will attempt to use a Google Cloud Platform service that I haven't used before to deploy the containerized application that we're creating in this video. So let's get started. I'm going to create a new repository. It'll be a satellite tracker, quick sat API. Make it public. I'll get ignored later. Give us an MIT license. So we've got our new repository here. I'm going to copy this guy. I'm going to open up PyCharm. We're going to download the repository. Well, PyCharm will clone the repository for us. So get from version control, URL, PyCharm will open up the code, and voila. First thing I'm going to do here is set up some stuffs. I like to cheat. I could have cloned another API. I actually have a FastAPI starter project, this guy right here. This I haven't touched in over half a year though, so it'll be a little bit outdated. First thing I'm going to do is actually copy the Nox file. I like Nox. I like the flow for development, and then you can also use the same Nox file for testing and linting your code in the build process. I'm just going to ruthlessly copy and paste. Makes life a lot easier, especially with the boilerplate code. It's easy to just copy it, and then you can modify it to your needs. This quicksat API, I've thought of the rough architecture, but I'm going to kind of work through it as this video progresses. All right, so the first thing I'm going to do is find some satellite data. I don't remember exactly where I found this before. I was messing around with satellite data a few weeks ago, but let's search for it. I think I don't remember where it comes from. Oh yeah, so let's track. Here we go. So, I don't think it has a file of all the data. See, each of these individually is its own file. And I think there are something like 20 or 30,000 or more satellites. They probably don't have a single file. It might just be broken down by category. So what we can do here is, my favorite is Starlink. It's been in the news quite a bit, and I think Starlink is a pretty cool idea. So we can take this file, and we could download it and save it in the code, but I'm going to show you another trick. We can actually fetch this file when the application starts up, when the API starts up, and then cache it, because we don't want to have to retrieve this file from this remote location every single time that the API receives a request, because that could potentially overload this site if we get a lot of requests, and I'm sure Celestrack will not appreciate thousands of requests. So we'll just grab it once when the application starts up, and we will store it in memory. Now that we have that, let's go back here. So we've got our Nox file. I've changed some stuff in newer Nox files that I've used at work. We're not going to use a database. I think we want to do that right there. Okay, cool. So we're going to create our API package. We're going to call it API. We've got our API, and then in here we're going to create a new file. We're going to call it main.py, and this is where we'll put the FastAPI application. There's quite a bit of stuff to remember when setting up boilerplate, and I don't remember it all. So I always go to references for FastAPI or whatever libraries I'm using so that I remember. Or I go to my own starter projects and I will shamelessly copy code from here. Just makes life easier. I might just copy a Dockerfile as well. Pretty straightforward. So it uses Python 3. We might actually see if there's a newer version of Python. I think 3.83 is probably the next version that is stable. Python 3, Docker. So let's just see what tags are there. 3.9 is currently in dev. Okay, so we can use 3.85 slim. 3.85 slim, so we'll use that. I like to use the Alpine version, but I've had some problems before with dependencies. Sometimes it's better to just optimize enough and not over optimize. And Slim does create smaller Dockerfile builds than just straight up Python image. I think it's good enough. Okay, so we're gonna leave this alone for now. We don't need this. This is for my open source project Migri, which actually is now in PyPy, so I don't have to install it from GitHub anymore. But my Star project is a little old now. It's not up to date. But we're not going to need Migri for this. And just get rid of this for now. Okie dokes. I'm sure there's some other stuff there, but we'll work on it as we go. Alright, so we're going to create a Docker Compose, not py YAML file. So we'll use Docker Compose for our local development environment. We're going to use version 3.8, and then we're going to call this API and build context dot slash, and then Dockerfile is Dockerfile. Let's see, let me reference a Dockerfile here. Okay, so here I have the entry point as a bash file. Let's go see what that is here. Okay, cool. So the reason I have a bash file is for waiting so that till the database starts up. We're not going to need that. We won't be using a database. So we just need this actually. We can have UVcorn be the entry point. And then over here, commands are passed into UVcorn. So we'll take all of that, we'll put it over here, command, like so. Oh. And I'm pretty sure we can actually set log level using an environment variable. Let's just do that for now. If it doesn't work, we'll change it up. And then we want hot reloading. So environment, cool. So log level, debug, and then restart, only on failure. If you set this to restart always, your containers will start up every single time you start up the Docker daemon on your machine. Found that out the hard way. Volumes, I'm gonna set up here API or dot slash API. We're gonna mount it to /app API. So you see here we set the work directory in the container as /app, and then we copy this API package into the API subdirectory inside the working directory, and then we install it from that location. So when we change any code here on our local machine, because we have the volumes mounted, it'll update the code here, and then the container will have the updated code. Forgot an important thing, ports. So we want, we'll just map 8000 on the local machine, our machine, to 8000 in the container. All right, so we're gonna create a setup file. And then we're just gonna copy the setup file from here, update the dependencies, and then we'll be good to roll. Oh, we'll also want to update, copy the flake8 file and git ignore. I don't set up files too often, only when setting up new projects or updating dependencies. So I tend to forget what all goes into them, so I'd just like to copy from somewhere. So we're going to go to PyPy and look at the dependencies we need and get the latest versions. So we can choose the versions that we want. So we're going to use HTTPX for retrieving the satellite data from its remote location. So like so. We don't need databases. We don't need SQL Alchemy. So we're going to look up FastAPI and see what the latest version is. 0.60.1. We're going to do the same thing with Pydantic 1.61. And then Unicorn 0.11.6. Okay, so when our application gets installed in the container, the setup will also install FastAPI, HTTPX, Pydantic, and Unicorn. And we're saying this is going to be Python 3.8 or greater. Cool. So that should be it for the setup file. And then in the test requirements file, we're going to install our application package. The reason why we're doing this is because we'll need it for the tests. I actually want to just install the requirements in the dev as well. Okay. Now let's set up the linting. These settings I grabbed from somewhere online. They're meant to work with the code reformatter, which is Black. There's some stuff that Black specifically does that the linter doesn't like out of the box, so we need to configure the linter for that. And we need the gitignore file. Just copy it from here. You might accidentally copy specific stuff that you don't need in your project that was relevant to the other project. So you just need to be careful with that. What I usually set as the path for the Docker Compose database container, I removed that from the gitignore. And for good measures, we'll copy the PyTest configuration. Oop. Okay. This is for capturing output. I think that's it. So now we can set up the config. So we're going to set it up similar to this. We'll come over here, we'll create a config file. Boom. PyCharm is warning us that no Python interpreter has been configured. So what we'll want to do is set up Nox. Now Nox works with pyenv. So I have pyenv here. I have it already installed. So installing pyenv is its own deal. You can do your research. The instructions on pyenv's GitHub is actually pretty straightforward in the GitHub's README for pyenv. So you'll want pyenv for this so that Nox can use different versions of Python, and pyenv will shim different versions so you can have different versions of Python that you use in different projects. Here, what we'll want to do is pyenv versions. So let's see which versions we have. So we have 3.83. Now we're saying that this project is 3.8 or greater. In a Dockerfile, we actually specify 3.85. So we'll want to have Python 3.85 locally on our machine so that we're working against the same version of Python as the container will have. So we want to do pyenv install 3.8.5, and it's complaining, so we're just going to update pyenv. You have to update pyenv to get the latest list of available Python versions. So this might take a minute. Cool. So pyenv got updated. Now we should be able to install the version we need. There we go. Beautiful. So now we're going to tell pyenv which version we want to use when we're working on our project. So we're going to tell it right now. So pyenv local 3.8.5. and you'll see that it creates a .python version file. And that's how PyEnv knows to use that version when your current working directory is QuickSat-API. We're going to install Nox. Now we're going to run Nox. It'll create a .nox directory where it's installing all the virtual environments. Each session here corresponds to a virtual environment that will be installed. So we see that some stuff is erroring out. It's because we left a file in an error state, a Python file. We'll fix that here in a little bit. Now, to make this Python interpreter error go away, we're going to configure it. We're going to add an interpreter, and we're going to select an existing interpreter, and we're going to set it to the dev interpreter that was created by Nox. So in QuickSat-API, we're going to go to the Nox directory, dev, bin, Python 3.8, boom. PyCharm will take a little bit to index, and then this should go away because all the dependencies that we'll be using will now be installed in the dev virtual environment. PyCharm will use that interpreter. Cool. So the error is gone, and now if you open a new terminal window, you'll see that the dev virtual environment is enabled. And now if you run pip freeze, you'll see that our dependencies installed. So now we can go back to configuration. So from Pydantic, we're going to import base config. I'm going to create a config class that's a child base config, and we need a satellite data configuration. I'm also going to copy this config. What this does is that it'll only pick up environment variables that match exactly the name that we specify here in this config file. So like, for example, we're going to call this satellite repository URL. That's a string. And we're going to set it equal to this. Actually, we're not going to set it here. This case sensitive means that it'll only use the environment variable satellite repository URL if it's all uppercase. So that's what this configuration does in this meta class. So now we're going to go to the Dockerfile, and we're going to set that environment variable. Repository. If I can type, that would be great. Cool. So there we go. Now, we want our main file. So we're going to start working on the API now. I'm going to set it up. I'm going to create a little app, which is an instance of FastAPI. And then let's create a health endpoint so that we can see our API running. Now, the cool thing about FastAPI is that it supports synchronous and asynchronous code. With the health endpoint, we're not going to do anything asynchronous, so we're just going to create a synchronous function, and we'll return OK. And let's return JSON here. The response doesn't really matter as long as it returns a 200 code. Containerization services just care about the HTTP code, and by default, FastAPI returns a 200. So this return payload doesn't actually matter. I think this is all we need to get it up and running. Let's find out. All right, so it's getting to the meat of our Dockerfile now. It's working on the dev stage, which just realized we didn't set the target here. So this is important because this is a multi-stage build, and the other thing too is we're not using this bash file anymore, so we need to get rid of it. That's what the error is here. So let's try it again. and see what happens. Okay, it's developed. The target name is develop, not dev. Well, Unicorn is up and running, which is awesome. Now we messed up in the setup. It's looking in the wrong directory for the app, or the wrong file, I mean. So here is where we messed up, right here specifically. So API is right, but it's api.main. So this is the package, and this is the module. And then app is referring to this right here, which is the variable that is an instance of the application. We're going to have to restart the container. Beautiful. So now let's open up Insomnia, which is my favorite REST client. I've tried to use Postman and I've given up a lot. The UI is just so cluttered that I don't want to deal with it. I'm going to create a new workspace here. Call it QuickSat. We're going to create a new environment. So this is beautiful because you can create environments for dev, staging, production, whatever, and allows you to just swap out URLs and passwords, whatever configurations. Makes it pretty nice. All right, so that's our base URL. The other cool thing too is you can set a color. So I like to set green as my dev color, and then yellow for any staging or remote develop environment, and red for production. That way I see here in the color, if it's green, I know that I can mess with it all day long. If I see yellow, I have to be a little more careful not to break the remote API for other engineers on my team. If it's red, it's production. I really want to be careful of anything that I'm doing. So I like that you can specify colors for the different environments in a workspace. So we're going to create this new request. We're going to call it health. It's a get. We're going to use the API base URL variable and then health. So there we go. Look at that. So we had a few little errors, but we got our API up and running, and now we have our health endpoint working, which is awesome. Give you a little pro tip here. So you can click send to make the request, but I like to use Command R on the Mac. It does the same thing. It's a shortcut, makes life easy, so you're not having to use your mouse. Cool, we see all the requests here in the API log, which is awesome. All right, so we're going to create the views. So I like to create a subdirectory for every major section of the API. There's a lot of ways to set up the file structure of the API, so really you can do what suits you, but this is what I like. I'm going to create a views file, and then from FastAPI I'm going to import, I think it's an API router, yep. And then router equals API router. We're going to make a new instance of the router. Now we can start to think through how we want our application to work. We just want it to make a simple REST API application that we can then deploy. It's not going to be super fancy. Really all that I see that would be applicable for this is retrieving, here let me show you the data. So retrieving all the satellites that we know of, and then retrieving all the data for an individual satellite. So let's do that. We're going to create two endpoints. Here, we can do router.get, and then it should be slash. So you'll see here in a minute what we're going to do in the main py file to make the routing work. This will probably be a synchronous function since we're not doing any IO def. Call it list satellites. Boom, we're not going to do anything fancy. We'll do that for now. Okay, so now let's go back to our main file. So we're going to import this views. So from api.satellite import views as satellite views, And then we're going to do app.include router. And then satellite views prefix equals satellites. So /satellites will be prefixed to all the routes in this view file. So now, if we refresh, what did we mess up here? Okay, my bad. Satellite views dot router. Okay, now we need to return something here. So we're just going to return an empty dictionary for now. We'll go back to here. We're going to add new request. Satellites, API, base URL, satellites. There we go. So we have our in this case, in JSON, it's an empty object, and Python is an empty dictionary. Cool. We need to get our satellite data now. I'm going to create a new file here, data. Normally, in a complicated application, I would abstract this out and create an adapter. Makes it really easy for testing as well. And we might actually do that at some point in another video. But for now, we just want to make it super simple. This is going to be our database. It's going to be in memory. Just like that. I'm going to make it a dictionary for now. You might need to change the data structure feature, but let's just roll with it. So I'm going to import HTTPX here. Now let's work on the functionality to retrieve the satellite data when the application starts up. So this one does need to be asynchronous. Path, we're going to make that a string. So this will be passed in through the environment variable. And let's see, do we want to return anything? No, we don't want to return anything. We just want to create populate our in-memory data structure here. Client, path as client. All right, so we just want to make sure that this works to begin with. Await client get. And we actually don't need the path there. So we could pass the path and here is a base path. If, like, for example, we were making a request in API, but now we're just calling an individual endpoint, so we don't need a base URL. I think it's JSON. I might be totally messing this up. I'm still getting used to HTTPX. We want to create a, we want to use a startup hook. I think it's startup. Maybe like that, maybe like that. Okay, this function does need to be asynchronous. Load satellite data. Now from API satellite data import get satellites. Wait, get satellites. Oop. Okay, so now we need the path. So we're going to import the config from api.config, import config. Now config. Boom. So config.satellite repository URL. So the config will retrieve the URL for our satellite data from the environment variable, and now we'll pass that into our get satellites asynchronous function. FastAPI object has no attribute startup, so let's go see what's going on. API.onEvent startup. Okay. Oop. Config object has no attribute satellite repository URL. Why not? All right, let's just print out the config. See what it is. So api.config.config object. Yeah. Let's print out the dictionary. Okay, so we've got an issue with our config class. let's look at our config here and see what's going on. Okay, we've got a problem here. It's a base from base settings. Okay, now it looks like HTTPX is having some sort of issue. So let's go back to our data file. So let's go to the HTTPX documentation, see what's going on. Async support, async, okay. That is what we need. That is where I messed up. Async client, and then we await, and I think that might work. Okay. So right here, it's not JSON, it's text. There we go. Now every single time the API starts up, it'll fetch this satellite data. This is kind of not useful. We'll actually want to convert this into a data structure that's useful. We're going to create another function, and we'll just make this private to this module. Actually, this is probably a stream. We can probably pass the stream through. Let me check out the HTTPX API. Or I guess we could just look at it here. So text does return a string, so that's fine. We'll just use the response at text. So we'll pass that into load satellite, and then we should be good. Response.text with 1x. Okay, now we'll want to process our satellite data here to load up this satellite's in-memory database that we're going to create. Now let's look at the satellite data so we can see what we want to do. And I'm actually going to bring up information on the satellite data so we can see what's going on. This is the format. First line has the name of the satellite. Makes sense. This is the satellite catalog number. Right here actually, minus the letters. And then the letter denotes the classification. So if it's unclassified, classified, or secret. And there's all sorts of other information. Really all we care about is the satellite name, the catalog number, and then the classification. Let's split up this text so we can do something with it. Satellite data. Now, you'll notice that the satellite data is in 3 lines. So we'll want to break up this text file and turn it into a list, and then we'll want to chunk these 3 lines so that we can extract the data that we want. We're going to do that here. Slash new line. And let's print that out so we can see what it looks like. Okay. Probably /r/n. That's what we want. There we go. So let's go up to the top. Here we go. Looks a little weird. Oh, okay. And you see that there's a lot of empty space, so we'll want to remove the white space as well. So we want to go to where the API started up, star length 31, and you see 1, the first line, and then 2 is the second line, and then next satellite. So we'll sanitize the data and remove the white space when we do the processing. So we'll do satellite data. Now let's combine the 3 lines into their own list. So every single satellite has its own list of its information. So we're going to do data. We're going to use list comprehension here. We're going to do I plus 3. We're going to grab slices of the list and use range. Okay, I think this will work. So what it's doing is grabbing slices from the index I and then I plus 3. See what happens. Fail. Total fail. Because we use the original satellite data, which is a text, instead of this list. That is why. Now we've got a bunch of empty lists. What's up with that? Because, again, this is satellite data, not data. Learn from my mistakes. What we want to do, so we see that we still have that white space. I'm going to strip the white space. And use list comprehension. There we go. We have pretty much a straddler here. Maybe there's some extra white space at the end of the file or something. It's possible. Possibility. We can do this. D does not equal empty string. There we go. Now we have the satellite data in its own list. So we have the name, we have the first line, and we have the second line. So we probably want our data structure to look something like this. With the key being the name. Then we have some values for attributes of the satellite. So like name. We could probably grab it from the key, but for giggles, we'll put it there as well. Classification. And what else? Catalog number. So we'll want to create this from this data. We have the satellite data now, so it's pretty simple. We just need to loop through it. For satellite and satellite data, we're going to create the payload. Attributes. We're going to make a dictionary here. Name is satellite. Remember, we have 3 lists in there. So satellite 0, the first string is name. And then we're going to have to do some other fancy stuff here for the other stuff. Oop. Now, we'll want to break up the satellite by white space. Like that. We'll print that out so we can see what it looks like. Cool. So we're going to want to grab the catalog number and the classification from that. So we're going to grab it from that first line. That is second element in index 1. And then the catalog number is the first 4 digits. And then the classification is just the last letter, the last digit. I think that's how you do it. Maybe. We'll see. Cool. Well, almost. 4, 5, 7. So we're missing. I guess it's exclusive. It's not inclusive. Yep. There we go. So this needed to be 5 because we wanted to go to index 4, but the slicing is not inclusive, so we wanted to do the index plus 1 to get the full 5 digits. That's cool. Simple as that. We now have the data that we want for the satellite. Now, we actually don't even need this attributes dictionary. We can just set the satellite with the name. The name is satellite 0. We're going to use that variable multiple times, so let's just create a new variable. Name, and then catalog number, and then classification, forgot the equals here. Just like that. So we have another print here. Let's get rid of that. Now, I forgot to commit my code when we got the health endpoint up and running. So I'm going to commit my code right now. Before I commit my code, I'm going to run Nox, so that it can reformat the code and run the linting. So reformatted one file. Made a change there. Okay, cool. This was probably over the character limit. So format, linting worked. So I'm going to change the check here to, I'm actually going to rename this to lint. We haven't set up any testing, so that's why the testing is failing, but that's okay for now. Cool, so we have our formatting and our linting running successfully. Let's just check to see what's going on. Okay, so Flake 8, we want that, we want that, we want that, we want that, we want all of that. So we're gonna add all of it. If you use git add and then dot for everything, just make sure you know what all you're committing. So I like to then run git status again and just check all the files and make sure that all the files that will be committed are files that I intend to commit. Now that we have our data, let's create our endpoints. So we want to return all the satellites. So we're going to import our satellites and list them out. Returning satellites is as simple as just grabbing all the values like this. We can use list comprehension. Actually, we don't even need that. Should be able to do that. Just grab the values. Now let's go to Insomnia. Internal server error. What's going on? I think we need to convert it to a list. There we go. Name should not be a list with a string inside. Oops. And I know why. Created a tuple there for some reason. There we go. Now we have all the satellites. So we do see that the satellites are sorted because of the file is already sorting the satellites by name, but just in case, we will use the sorted function to sort the satellites. We're going to use the key function here, which is going to pass in every single element. Values are a list of dictionaries, so that's what S is, and we'll just access the name so that the sort function will use the name to sort the satellites. Okay, was not sorted alphabetically. Cool, now it is. I'm noticing here in the request that we're having redirects, and that is because we have slash here. If we remove the slash, then this endpoint can be accessed without a trailing slash. And we should see that redirect go away as so. Now, let's retrieve an individual satellite. router.get, then satellite name. For now, let's print satellite name, and we'll return an empty dictionary for now. Let's set up the endpoint. The satellite name, and we see that the endpoint works. And now if we go back to PyCharm, we'll see that the name is available to us. There's a possibility that the satellite doesn't exist, so we'll want to put this in a try except. Satellite name, which is the key in our satellites dictionary. Except key error. Status code is 404. Detail is satellite not found. Let's test it out. Starlink 100 does not exist. Beautiful. 404. Otherwise, we'll get 200. That is awesome. Let's remove this here. Let's go check out the documentation for the API. So one of the cool things about FastAPI is that it generates docs for you in OpenAPI format. Now, one of the problems here is you see that there's no available data. It's because we haven't set the response model. So let's do that right now. We're going to create a new file in the satellite. We're going to call it models. Okay, and we're going to use Pydantic to create the models. If I can type, that would be great. Base model, class, satellite, base model, name, string, they're all strings. Okay, now we're going to go to reviews from api.satellite.models, import satellite. Here, response model. So we have like a list response here. So we actually have an object or a dictionary with a key that is a list or an array that then has the satellite data. So one of the things I like to do is in just API, I like to have a generic models file and create a list response model for that. We can actually make it generic. I don't actually remember how to set it up. I'll have to look it up. Okay, let's look up Pydantic generic. We need it to be generic. We actually don't need it to be generic, but we want to make it generic if we want to add other endpoints. It'll be easy to swap out the response model so that the list response will have the satellite data, but we could use that same response model for other response types. Here we go, generic models. Type var, that's what we need. Yeah, why not? Pydantic.generics. That's why I couldn't find it before. Generic model. Boom. And then we pass in the generic type. So then we can do this. We need a list. type T. Now, we can come back to the views. We're going to import that list response model. So now we can do response model equals list response. Satellite. Here, the response model is just satellite. Now if we go to the documentation, so this is to retrieve an individual satellite. You see the example return format or the example payload. And for all satellites, now you see that results is an object with a results key pair, an array that has the satellite data. So that generic list response model can now be swapped out. We can use we can specify other data for other endpoints. We see the API, it's still working as normal. It's all good to go. And that's it, folks. That is how you create a simple API using FastAPI. In the next video, we're going to deploy this application to Google Cloud. We are going to check out Cloud Run to see how that works. I've never used Cloud Run. Hopefully this video is useful to show you how to create a simple API using FastAPI and asynchronous Python. Till next time, take it easy.